So remember from yesterday, we should have looked at our triangle challenge, which was basically to look at, given some information, how many triangles can we make. So the information that they said that's going to be the same for all of your triangles is that this angle is going to be 30 and this side is going to be 8 inches. Okay? And then the bottom part doesn't really matter. What they wanted you to look at is, depending on the length of this additional side, can we create, or how many triangles can we create? And so they told you to start with 12 inches and then work your way down. So basically what we're looking at here is the case of side-side angle. And we do need to say it in that order, okay? We're all big kids and can be mature about it. One of my kids last hour, it took them several minutes to understand why I made that statement, but once you figure it out on your own. Alright, the biggest thing here is that your angle is going to be the not enclosed angle, meaning that it's not the angle that's in between. And in geometry, you are basically told that this is not a congruency property, that you can't use it. And that can sometimes be the case, and that's kind of why they went ahead and just say you can't use it, because it can be a little bit tricky. And it does cause us to have to look into this case a little bit deeper. And so let's see. So, when we look at our triangles that you could create, we actually end up with 12 triangles, okay? So, if you started with 12 inches, it's going to create one triangle. If you did 11 inches, it will also create one triangle. 10, 9, and 8 also just create one triangle. What becomes different is when I get to 7, notice that I can put my side in such a way that my top angle is obtuse, and it's going to create a triangle. But I can also put it in such a way to where my top angle is acute, and I will create a second triangle. And the same is going to be true for 6 and for 5. Okay? Now when we get back to 4, it again is just going to create 1, because if we try to angle it in, it's not long enough to create a second triangle. Does that kind of make sense? Now, what do we notice about our sides that created 2 triangles? They're all less than 8. So 8 was our given side, right? And so notice that my sides that are bigger or equal to 8 can only create one triangle. But all of my sides except for 4, right, can create 2. Now, what's going to be special about 4? It's half of 8, but what's more important is what type of triangle does this create? Right triangle. A right triangle. And so in this case, notice that this side equals the height of the triangle. Does that make sense? So once you get down to a point where your side is now going to equal the height, or in other words, create a right triangle, there's again only going to be one option. Okay? So, and that's what this is kind of laying out. So notice that when, there should be an equal to bar on that, when your side is bigger than or equal to your original side, then there's only going to be one option. When we have our second side is smaller than, there are 2 options, as long as it is still bigger than our height, which is what this last one is. If it's smaller than it, but it equals the height, there is still only one option. So remember that this is important, that we're still dealing with laws of sines. So we're still going to be using our law of sines, but we're specifically looking we're dealing with the ambiguous case, which is side-side angle. So we only have to worry about there being two options when we're given two sides and an angle that's not enclosed, okay? And you don't have to have this memorized. It's basically a laying out, kind of what we talked about before. If our A is less than our H or our height, notice that we're not going to be able to create a triangle. The same thing over here. If our A is smaller than our B and we have an obtuse angle, we're also not going to be able to create a triangle because it's going to be too small. Okay? Then the last example that we talked about is if that second side is equal to our height, we'll only have one triangle. And also if it's bigger than our original side, no matter if it's acute or obtuse, we only create one triangle. And then in the middle here is those couple of middle ones that we talked about. If our A, or the new side, is smaller than our B, but is bigger than our height, that's where we kind of hit that perfect spot where we can actually create two different triangles. Okay? Now, like I said, you don't have to memorize these. You can kind of keep them in mind to kind of help you figure out, should I be looking for two answers or not? But we're going to look at algebraically how to figure out if we have two answers or not. But this might be a good way to kind of go back and check this out. Alright, so first up, we're just going to be looking at a law of signs problem. So we're going to start the problem like we would any of our other law of signs problems. Okay? So what might it be helpful to first do? Draw a picture. Okay? Do you have to draw a picture all of the time, like for your homework or on a test? No, but I would be careful because it's really easy to mix up which angle goes with which side and so forth if we don't have a picture. So I would usually recommend it. Now remind me, does it matter which angle I put where? Agreed. It doesn't matter where I put the angles, but I just have to make sure that I'm consistent and then put my corresponding sides in the right spot. So if, let's go ahead and label this side as our 42 degrees for big A. They gave us that little a is 22 and little b is 12, which means that this angle is big B, this angle is big C, and that side is little c. And they ask us to find the remaining side and angles. So, what side or angle do we have enough information to find right now? Well, they already give us big A and little a. We can find big B. So remember, we have big A and little a, so we know that that's going to have to be the first ratio that I use. So little a over sine of big A. But then remember, in order to be able to solve for another variable, we have to have at least one of the parts. And so since they also give me little b, we know that that's going to be our second ratio. Are we all okay with that? Alright. So then we can just plug in. So they give us little a is 22. Big A is 42, little b is 12, and then I have sine of big B. So what does my first step need to be? Agreed? Gonna multiply sine of big B to both sides. And then of my fraction, Now, I'm writing out all of the steps just so that way you can see where I'm getting everything from. Do you have to write out all of these steps every single time? No. Okay. If you can skip that second step that we did, that's fine. Okay. Then what's our last step? How do I get B by itself? Not multiplying because it's an operator, but I'm taking sine inverse of both sides. Yes. So I want to take sine inverse of my right side, and then we're going to plug it into our handy dandy calculator. So if we don't have out a calculator, we need to get one out now because we're going to be using it quite frequently today. Okay, so let's plug all of that in. You need to make sure that you put your parentheses in the correct spot. Remember that you do have to end your parentheses after that 42 before you divide by the 22. And you also need to make sure you're in degrees. And what do we get? So we get 21 point what? 4, just do 2, fine. 41 degrees. Okay? Were we all able to get that in our calculator? Okay? So then from there, what do we want to find next? We have to find big C before we can find little c, but big C is pretty easy to find because what is big C going to be? 180 minus A minus B, right? So we get what? 116.59 degrees. Yes? And then from there, can we find little c? Yes. The only thing that I will say is technically we could use our B ratio now to find C if we needed to. However, notice that we had to round to find big B. So if we use a rounded answer, basically we're like making our rounding error much larger. So if there's any way to use the original information that they give us, that's what we want to use, if at all possible. Now sometimes that won't always be the case, but this time we can. So I'm going to set my A ratio equal to my C ratio. So we get 22 divided by sine of 42 degrees equals little c divided by sine of 116.59 degrees. So notice in order to solve for c, I would multiply both sides by sine of 116.59 degrees. Again, we're going to plug all of that into our handy dandy calculator. Make sure that you put your parentheses in the appropriate places. And what do we get? 29.40. And we are in inches. So, up until this point, this problem has been exactly the same as all of our other sine or law of sine problems. Agreed? Okay. But what's different is they gave us two sides and an angle. So we have to check and see if there's a second solution. Are y'all with me? Okay. Now remember that I said that if we end up with a second solution, notice that one of your angles is going to be acute and the other one is going to be obtuse, right? Because we angle it in or we angle it out, so that is going to create an acute angle or an obtuse angle. But the way that the triangle is set up, is that acute angle and the obtuse angle have to be supplementary. Okay? Are y'all with me? So in this case, for my first big B, I got 21.41 degrees. If we were to get a second answer, the obtuse angle would be the supplementary angle to my original angle. What does supplementary angles mean? They add up to 180. So how could I find my second option for B? Okay? And usually our notation for our second answer is to use a prime. Okay? If you want to use like a subscript instead and say like B sub 2 or something like that, that's okay as well. Just make sure that you indicate in some way that this is the second option. Are you all with me? Alright, so we're going to take 180 degrees and subtract big B. And what do we get? $158.59 degrees. Now, from there, we're going to treat it basically like it's a new problem. Okay, so I found my big B. So then what can we find next? Your big C, right? And so that part's not going to be different. Again, I'm going to indicate that this would be my second option for big C, right? But we're going to find it the same way. The only difference now is instead of subtracting just big B, we're going to subtract that second option that we got for big B. So B prime. Okay, and what do we get if we do that? Negative what? 20.59. Now, is that a valid angle for a triangle? No. Okay. So, since we can't have a negative answer, we know that there is no second solution. Alright, so any questions on that? Yes? No? Maybe? Yes.
The first one, you want to gravity is, and for the second C, you would subtract A and the B, figure it out. Okay.
Yeah, so just like I did on my first one, right?
Mm-hmm.
They give me A, so that doesn't change. Anything that's given doesn't change ever. It's only the stuff that we found. Does that make sense? So I did A minus B, okay? And basically, like I said, once we find our second option for B, we're basically treating it like it's a new problem. So I still want to find big C. They gave me A in my original problem, so I'm still using that same A, but now I'm using my second option for big B instead. Does that make sense?
Yeah.
Yeah.
So would we ever do that for like actual assignments? Or we just do that for degrees?
So if, say we got a second option for C, and we'll look at an example of this in a second, that we get an actual angle, then we would want to go ahead and go on and find our little c that goes along with that as well. Does that make sense? So potentially, we would have 3 answers for our first triangle, and then 3 answers for our second triangle, if there are two triangles. Does that make sense? Because this one asks us to find the remaining side of the angle. Like if the question just said find like big B, right? Then you would just have to find 21.41 and then your second option would be 158. So it just depends on what the question asks you to find. Does that make more sense? Other questions? Okay, so this was one solution, right? What were our other options? No solution. Yeah. Good guess. I don't know what gave you that. I don't know. Alright, so again, let's go ahead and start by drawing a picture, just because I think it's helpful as a reference. So again, this is going to be big A, so this is 85 degrees. This is little a, so 15. Little b is 25, which makes this big B, big C, and little c. Okay. So again, we're going to start this process like it's our normal law of sines question. Okay. So again, what side or angle do I have enough information to find right now? Big B, yes. So we have A and big A, so I'm going to use my A ratio. And I'm going to use that to find big B. So again, this time we have 15 divided by sine of 85 degrees equals 25 divided by sine of 15. So, what do we do? We solve for B. So multiply sine of big B to both sides. And then also multiply by the reciprocal. And then what do we have to do? Take the inverse. So we end up with big B equals sine inverse of 25 times sine of 85 degrees divided by 15. So we plug it all in, and what do we get? Why? I agree, you should get a domain error. Okay. Okay, so yes, let's look. So 25 times sine of 85 degrees divided by 15 is approximately what? 1.6. And 1.6 happens to be greater than 1. And why did you say that it being greater than 1 causes an issue?
Because I think that's like
That's the thing. Okay. I agree with you. You have the right answer. I just need a reason. Why? Okay. Did anyone help them out? Why can this stuff on the inside of my sine inverse not be greater than 1?
well, because it's out of balance on the unit circle.
Ish. What do you mean by out of bounds?
Like it's greater than the value sine can be.
Correct. Yes. So it's greater than any value that sine can be. So if we think about like our graph of sine, remember our minimum is at -1 and our maximum is at 1. And for our sine inverse, we're working our way backwards. We're saying what angle gives me 1.6-ish, right? But if all of my sine values are in between -1 and 1, there's not an angle that's going to give me something that's 1.6. So we could say, therefore, there is no triangle. Okay, so whenever we get a domain error, okay, I would go ahead and double check and make sure that you didn't mess up somewhere. But then most of the time it's going to indicate that there is no solution. You can also check yourself by just plugging in the inside stuff. And if it's greater than 1 or less than -1, there's not going to be a triangle that makes that true. Any questions about that? Alright, so we covered one solution, no solutions. What's our last option? 2 solutions. Alright, so again, let's draw a triangle. This time they give us that A is 20.5 degrees, little a is 12, little b is 31. So again, what do we have enough information to find? Big B. So notice we've been setting it up the same way. We can also, if we want to, use the reciprocals of everything, which can make our lives a little bit easier. So as long as you do it for both of them, we can use the reciprocals of our fractions. Because since we're going to be solving for big B, sometimes it's nice to just start with the sign of big B on top. So plugging in our information, we have sine of, they give us 20.5 degrees divided by 12 equals, we don't know what big B is, divided by 31. So then what would we have to do to solve for big B? Agreed. And then take sine inverse of both sides. Okay, so what do we get for big B?
Um, 94 point, wait,
64?
Yeah, 64.
Okay. So then what can we find from there? Big C. And what is big C going to be? Agreed. And what do we get for that?
94.72.
Okay. So now we have big B, big C. What's the other thing we have left to find? Little c. Okay. So again, we want to try and use the information that they give us. So I'm still going to use A in sign of A. But now we're solving for little c. So we can go ahead and plug in our 12 divided by sine of 20.5 equals little c divided by sine of 94.72 degrees. So little c is going to equal sine of 94.72 degrees times divided by sine of 20.5. Again, plugging all of that into our calculator, what do we get? So am I done? That's it? We good to go?
What is that?
We gotta check and see if there's a second solution. Now, in this case, our directions tell us that there's a second solution, but that's not always going to be the case. Your directions are going to say, solve the triangle for both solutions if possible. Or list both solutions if possible. Does that make sense? So you're going to have to check and see if there's two options. So how do I find my second option? Find my supplementary angle. So I'm going to do 180 degrees minus my big B. So what do we get for B prime? What? 159 point what? That doesn't sound right.
It's just 164.7.
Correct.
I think you subtracted the wrong thing.
It's 150.
150 what?
150.22.
Okay. So that's my second option for big B. And again, we're going to continue on just like this was a new problem. They gave me little a, little b, little big A. Now this is my big B. So what can we find next? Big C, yeah, our new big C. So C prime. And we're still going to take 180 degrees, subtract A, but now we want to subtract B prime.
Is it 44.28?
Somebody get the same thing?
Yeah.
44.28 degrees. And then that's when we know we have two solutions, because we were able to find a second angle that makes it true. We know that we have a second triangle this time. Does that make sense? Okay? And then, like I said, we want to continue on. So now we need to find the little c that's going to make this true, right? But notice, because my a's were my givens, so that part's not going to change, right? The only part that's going to change is what I plug in for my big C. So instead of the 94.27, we're going to use the 44.28. And again, plug all of that into our calculator. And what do we get?
23.93 meters.
23 point what?
93.
938. Yep. We all alright with that? Questions? Concerns? Alright, so that's our ambiguous case. We do have one last thing we need to go over though. And that's going to be our area. So we actually have two new formulas for our area of a triangle. The first one is using law of sines. The second one will be using law of cosine. Now, this looks like a lot, but basically they just wanted to go over all of the different combinations. So notice, it's always 1/2, and then it's two sides. So if I have little b and little c, it has to be big A. If I have little a and little b, it has to be big C. And if I have little a and little c, it has to be sine of big B. So basically, it's always the two sides and the angle in the middle. Does that make sense? Now, you don't have to have this memorized. I will give it to you on your test. You just have to know how to use it. Okay? But like I said, it's always going to be the two sides and then the sine of the angle in the middle times 1/2. Okay, so let's look at an example. It'll be rather fast. So it says find the area of a triangular lot having two sides of lengths 90 meters and 52 meters and an included angle of 102 degrees. The big thing here is that they say that it's the included angle, so then it doesn't really matter what we label each of those sides. We're basically going to be using that formula. We're going to plug our 90 and our 52 in, and then our 102 in for our angle. And then we plug all of that into our handy dandy calculator. And what do you get?
Um, 2,288.86.
And what's my unit? Meters squared. And that's all it is. Question on that?
Although it was 86.5, still would be 86.
What is like, so when you're using that formula, what is like the BC, AB, and AC? What are those stuff for?
So that's why I gave you the diagram.
Oh, I know.
So basically, the reason that they give you all of the options, they say like any combination can work, as long as it's two sides and the included angle. And that's going to be the big part, because you might not always have them labeled that way. They could use R's, Q's, and S's, or X, Y's, and Z's, but as long as it's two sides and the included angle, that formula will work. Does that make sense?